Okay. Hello, everyone, again. I apologize for the inconvenience. I really hope that it will be working now.
I have a question in the meantime. Can you show us where the project is to test to try, like on the website which you mentioned earlier?
Can you please repeat it? Sorry, I had it very low at the beginning. Were you asking about that video that Jan mentioned at the
Yeah,
beginning of
exactly the tutorial.
this tutorial? Yes, you can actually find it on our YouTube channel. So when you go just to YouTube and Cherenka Consulting, it should be like Cherenka Consulting Preprocessor. And yes, this should be this one.
Okay.
This
Thank you very
this
much.
video. So maybe I can send the link to the video in the chat. But I think we are going to re-upload the video. There was a problem with the soundtrack that it was doubled at a certain moment. So I'm not certain if this is the final version or we are re-uploading it today, maybe. Yeah, so that is linked to the video. So you can go through it. It's like step-by-step tutorial explanation of actually our one of our basic tutorials that we have for the preprocessor. And maybe I go backwards a little bit in here, that when you install our ATENA 2024, there's ATENA Center, and usually you get the icon of ATENA Center directly on your desktop, or you can use the Windows search to find ATENA Center 2024. And in here, beside our main tools, you can find some supportive information that might be helpful. Either you can go directly to the folder with examples, where are the examples that that are part of the installation, or there's documentation there, all the PDF manuals that you need for this version. And actually here in tutorials, you can find more examples that you can go through and see how they are defined. And the first one that is in here, that shear wall with round opening, that is the one that is shown in that video tutorial. And in here, when you go to this, you can either go to show tutorial, which opens the PDF manual of this example. So you can follow also this PDF version, how to proceed. And I will just like briefly go through it. And then I have, as Jan said before, I have some more tips maybe in ATENA preprocessor, but you can of course have questions as well if there is something that is not that you want to go in detail. And maybe, okay, I will try to mute our participants. So I hope you can hear me. It looks like I shouldn't have reviewed it. Good, great. Thanks for replying that I know. So yeah, first I will just like really briefly go through this example, and then I will open the new preprocessor, the completely empty project, and I will show you some more things. So this is the example of the wall that has opening. Maybe I will switch this to solid so you can a little bit better see the geometry of it. And it's always a good idea to follow the input tree data that is on the left side of your screen. So first starting with definition of the geometry. So we defined like the the parts that are the beams and the wall that is in between those beams. Then after, and also beside the main geometry, we have, of course, also the discrete reinforcement that is inside this example. So that is everything defined in the geometry part. So when that is done, we go to the materials. And in here, you can actually see either if here it shows the materials, then you can open also materials in here. That shows you which materials are defined in this example. Maybe I go separately just to the concrete first. So you can see that the beam materials are here, concrete beam. You can also see it here and in the table. And this material that is actually a combined material, which is like containing smeared reinforcement. That middle part that is in here, that is this concrete wall, and that is our standard nonlinear cementitious material that is plain concrete, and it's actually reinforced by discrete reinforcement. That is defined in here. There are like different reinforcement materials defined based on the different rebar like diameters. Sorry. And this is just like definition of the material, but you are not assigning it to the geometry at this part of the materials. You are just defining the material laws. When the materials are ready, then you can continue with building element types. And that is actually part where you are assigning the materials to the geometry, which can be seen, for example, in here, that there are like beam types. And those beam types, they have concrete beam materials assigned, and the static model is 3D solid. So then it's like connecting information about the geometry, what sort of static type or like element types will be used for meshing that area. In here, you can also see to which geometry parts it's assigned. So the beam types are assigned to beams with a beam material, and the wall types in here that is assigned to the geometry, solid number 1, and there is material that is the cementitious that is also visible when you open it. You can see the concrete wall, and that is defined in here. When I continue to the reinforcing types, that is basically the similar things like that is for the geometry of the concrete part, but this one is for the discrete reinforcement. So you are basically describing which lines in your model have assigned the material, depending on also your bar diameter that you can specify in here. And also we can specify bonds, for example, in this area. So at this point is the moment actually why it's good to follow the tree, because once you have those building element types and reinforcing types assigned, you can start with meshing. And it actually, if there was like no meshing parameters at this point, you still can mesh with the default parameters. So when you go to FE mesh generator, at this point you are able to preview the mesh. And actually, if you want to specify the size of the mesh or type of the mesh or other things, you can assign it in this FE mesh parameters. That is something that was covered a little bit more in the tutorial, so maybe you can follow it later on in the video. I will also cover part of the meshing parameters later on when we finish this brief overview. So then when the mesh is ready, we can jump to analysis settings. And in this case, maybe I'll not show the mesh in here. So you can see those other parts like supports, how they are shown in our view here. So in our load cases, we are defining how we are going, what sort of boundary conditions and also loading we are going to apply on our structure. So this structure is supported at the bottom beam, like at the bottom surface, and then it's just loaded here at the top beam on that bottom line in here, and it's pushed vertically, so the shear stresses are created like through the wall. So it's shear loading. That's why it's called shear wall with round opening. Yeah. So in these load cases, we have like the defined supports and prescribed deformation. Then we continue to boundary conditions, which is like it's interconnected with load cases. So for the load case with supports, we are describing like how it is support, how the structure is connected with master slaves in here. That is something I will cover later on a little bit more too. And then there is also described the displacement, which is like prescribed deformation here on this line. It's marked when you like press it in the table. It always shows the boundary condition you are interested in. Yeah, then we go to monitors, and actually in the tutorial I added one more monitor. This is like the standard example that is in your installation, and there we have just like two monitors. One is reaction on like at the bottom at the support, and another monitor is displacement of this edge. So you can then create the LT diagram for the structure. And actually one thing that I added in the tutorial was one more monitor, which is basically here on the line that catches reactions there. I just wanted to show that it's possible that you don't have to always like record the reaction only where the structure is supported, which is like standardly what you can do, but you can also record the reactions at the place where you are assigning the prescribed deformation. So we can go to the monitor and create like this is the reaction and on the line, and we want to record reactions. It's in direction Y, and we have to use the summation, and this is something that you can apply on this line, and using enter it creates the monitor. It's here, the monitor I just created, and I'm just showing it for the sake that you can see that either you're recording the reaction at the support or where you are prescribing the deformation, and it should be the same when you are looking at the LD diagram in the post-processing when you are checking the results. Yeah, and there's final part. It's the task. It's basically where you are describing your loading history. So you are saying how your structure is supported and how it is loaded, and you are describing how much load, what is the magnitude of load you can change with those interval multipliers, and then divide it into as many steps as you wish. And that is like basically just briefly how this nonlinear simulation can be done. I will just start to run it on a background, but maybe we can at the end have some quick look at the results. There will be time for it. And at this point, I will just close it and I will try to open just like the empty ATENA preprocessor and show you a little bit more things that were not really covered in the tutorial. And in general, I actually was focused more on the geometry part for creating geometry, a little bit more on meshing and then the analysis. So in case of you have some questions regarding material or building element types, it's something that we can cover later on as well. So at first, I would like to focus a little bit on this grid that might be very helpful sometimes when you are creating the geometry, because normally you have this ability to snap the grid that is defaultly checked. And that means that when you are creating the points, the basic tool for creating geometry, you can see that as you are like snapping that grid on the right side here in point setting, that it's changing the coordinates in here. And that is something that can be sometimes helpful, sometimes not. So that's why there are some tools that I will get them a little bit later on. And one thing I wanted to point out that you can see that it's snapping just the grid. So you can see that it's changing only X and Y direction, not the Z direction, because that grid is only like in one plane. And so you can either direct click with your mouse and create the points. You can see how the points are being created. They are saved with IDs, or you can like change manually coordinates in here and save them as well. But there is one more thing that you can use as well here. There is a command line at the bottom where you can, as explained in here, you can either define the point directly, or you can actually use length and azimuth, which I will show you how it works. So first we are defining the point that is like, for example, 111. Pressing enter is creating the point. It's point 111 is point number 6. So we know which one is it in here. And if we use this at length and azimuth, that is something that is like saying the length, that is like how far it is from the last point that was created, which is the red one in here. And azimuth is the direction. So that is something, if you know like the distances between your points of the geometry, so it's easier for you to define it directly like this. So for example, we can say like, sorry, we can say it's at 2, that azimuth is just in degrees, because the azimuth, important thing, it's following that grid that is there. So it's lying in this plane. And this is one thing that, I mean, it's lying in the plane, sorry, it's lying in the plane, just like the same plane as the previous point. And when you change the view and this section, because right now we have the grid in X and Y plane, you can go to, for example, that you switch the view and you have grid in Z and Y plane. And at that moment, that azimuth is following that plane, or a plane that is parallel to this plane. Yes, so this is like, it might be helpful tool for one of the other things, how to create geometry. So once you escape this point settings, it's like returning the command line to default, but you can the similar thing with which I showed just now on points you can use on any type of entity that is defined by points. So you can define points for the line segments the same way with this like azimuth ID, or with coordinates the same thing is applied on arcs or nerve curves as well. So when you like open it, you can see that in command line you can work with it as with points. Yeah. So this is one of the first things I wanted to show. Then I was showing in the tutorial how to work with arcs, but I didn't show you that when you don't have like just partial arc, but you want to work with full circle or circle and the surface, there's like actually checkbox directly for it. When you are going like to create arc and you want to create actually the whole circle, you need to check this checkbox, and then you just need to define, of course, like the center point and then the start point that is creating the whole circle. So basically, that angle point is like redundant at that moment because you just can choose whatever, and it creates the whole circle. Yeah, that is one thing. Then, in case of you are working with NURBS curves, sometimes you can have like the curve that you create, and then you realize that it's not exactly the shape that you wish for. So what you can do is that you select the curve. So you have to choose this selection. You select that NURBS curve, and actually here next to the curve table, there is button edit control points, and at that moment you can actually work with the NURBS curve, and you can slightly change its shape. There are two options. There are some control points for the NURBS curve that are like setting its shape, and those points either you can translate them, or there is another version that you can use the weight of that point. So basically you are just like shifting here the weight, and it show you the preview. Sorry, I didn't choose the point. Which one it should consider. So here you can see that you can change the shape, or in the translate control points, you are just like again you select it, and then you are working with it. You can change the shape as you wish. Yes, so this is one of the other things. Then I would go back to translate the dialogue that was used quite a few times during that tutorial, and it's actually very helpful for multiple things. And there, I think during the tutorial, like most of the time, it was used for either extrusion or copies, but you can also use it just for moving. When you are like in this basic settings, when you don't have check the copies or check extrude, it's basically just moving something. So let's say we are just moving something, we will move this circle, and in this select geometry, you can see that it's selecting all the parts that are on the geometry. But it might happen to you that you have a little bit more complex geometry. There are too many points or lines or something, and you just want to move one surface. So you can actually here uncheck like points and curves that they are not selected anymore, and it's selecting only the surfaces, solids, and interfaces that are in here. So that might be helpful when you have like more geometries, or you didn't select it into different layers yet. Yeah, so that is the selecting geometry. Another part here is when you are choosing those start point and end point for your vector, where it's going to be translated or moved. You can work with some helpful tools here, because sometimes it can happen to you that you are moving with your mouse and you accidentally change your coordinates in here of that point. So you can actually use to prevent this button unlock all, and it's not changing your coordinates anymore with moving of the mouse. And this is doing like this unlock for the whole or all coordinates at once, but you can actually here separately choose like which coordinate should be locked and which doesn't need to be locked. So you can see that only y coordinate is, for example, changing with the movement of the mouse when it is unlocked. Another helpful thing is like set to 0, because very often you are working with like sort of unit vector or something that you know that like you are starting at the 0 and you just know by how much you want to translate it. And another helpful thing is this preview that you can see where you are going to translate it. And once you select the point, it's doing that. It's finishing the operation. So it moved our surface as we wanted it. So these like selection tools or other buttons in here that might be very helpful. And yeah, this is actually for, like, as I said, moving, doing copies or extruding with translation, and very similar options you have in case of you are not doing translation, but you are scaling the geometry. You can also select that you are just like scaling the geometry, or you are doing copy of this and scaling it. And that selection process and settings is very much similar as in translation, and that's very similar in this third tool that is for rotation. Just maybe one thing that I can mention here, revolve is basically extrusion, but in case of you are rotating some geometry. Yeah. Okay. So when we continue, basically.
Maybe I will just interrupt, Michaela. Are there any questions so far, or something you would like to cover more deeply, or something is not clear?
Yeah, I'm sorry, I'm probably like machine gun a little bit.
I think either you have two options: either write your question into the chat message, and then we are following the chat message, and if there is a question, we will stop and answer it. Or if it is more complicated, more difficult to explain, please just don't hesitate and turn on your microphone and ask the question. So just basically, Michaela is now going through some little bit more, maybe trickier parts of the defining the geometry. So right now she covered the definition of the points and this translate and scaling operation. Of course, if you want to go through more details, we again recommend to look at that video tutorial. So if there are no questions, I will give the word back to Michaela. So please go ahead.
Okay, thank you. In case of if you notice some question in chat and I'm not answering, please remind me to check it too. Yeah. So another part that is in here, if we continue in this toolbar of like adjusting the geometry, there is like separate geometry, for example, or this is collapsed geometry. So the separate geometry basically can apply it, for example, on this part, like on one curve. When you select some geometry that you want to separate, it's good to actually watch in here in the message if that operation actually was successful. So once you select it and press enter, okay, you can see that, yes, separating was succeeded and it created 3 new entities. So maybe we can just look in like here in curves. This is the table of curves. And when I'm selecting here these curves on the side, you can see that it shows me 2 curves. So it's correct. One curve is there that is connected to the surface that is in here. And there is also one curve that is completely extra that was just created because I made it separate from the geometry. And going backwards, if you want to do like the inverse operation, you can just collapse it. So you select that area where the entities needs to be collapsed, and you can see here that collapsing was succeeded and 3 entities were collapsed. And in here, again, I'm selecting table 2. I will select just the curves here, and it shows me only one curve because that other one was collapsed.
Just one more note here at the bottom, on the bottom right, you see always the number of selected entities. So now as Michaela draw the box over the line, here at the bottom with the little arrow, bottom right, you see there is 1 selected entity. So this is maybe also important to mention, this box at the bottom. Here you can control the snapping to grid points and so on. And also on the right, the most right button shows you the number of currently selected entities. So this you can also use to check whether really at that location there is only 1 entity. This is sometimes useful if you have some complicated models. Some entities may be overlapping each other, and it may be important to check that you know what is happening. Yeah, so please, Michaela, go on.
Yes. So another maybe thing is like regarding geometry or in general in Preprocessor is using the possibilities of the tables that are giving us a lot of informations. For example, when it comes to geometry, we can like click on the row and actually it shows us which geometry we selected. We can select just one, or pressing Control, we can select even more geometries. And besides, like, for example, when we are here in curves, when it's telling us the start point and end point of that curve, it can also tell us if it is like connected to some surfaces. And for example, in
Also, please show the labels, Michaela. Show the labels.
Yeah, I'm getting there. Yeah, I'm getting there. I actually wanted to just show that in case of solids, sometimes you need to know also the orientation, and there are like even the orientation written in here. Okay, so never mind. I'm gonna go back to curves. One thing is that you can actually sort of hide the curves here. The labels that can be helpful too here in the checkbox when you are like finding, for example, you have error message with the curve ID something, so you can find the curve and you can select the label so you can see which ID or which geometry might be problematic, for example. So yes, that is one thing, and in like again in geometry, but also in other parts, you can have some helpful buttons on the left side from the table and here. And that is something that we are actually currently preparing a better detailed manual that will explain all those buttons too. So, I mean, if you have questions, we can of course cover it, but hopefully soon you will get also the manual that is covering it better, that you can find it even in our documentation. So this was mostly about the geometry part that I wanted to show you, and I would continue now with the meshing. Sorry, I will open our tutorial example, and when we show the finite element mesh that was already defined in this example, I just wanted to show you how you can play with it a little bit. One thing is that I wanted to point out, this helpful thing that is it's called equidistant. You can find it in this FE mesh size, and you see that it's checked for this case. So when I uncheck it, and I will generate mesh again without it checked, you can see now what is doing. It's basically keeping that mesh that it's parallel. So it's helpful. Sometimes you want mesh that is really parallel, that there are 90 degrees in between lines. So that is this equidistant that can be helpful for these purposes. Yeah, and you can see that this part was assigned to geometry 2 and 3, which are those beams that at the top and the bottom. That's why they have this mesh that is slightly tilted. And when I checked it back and generated, you can see that it's nicely parallel again. Yeah, mostly regarding the FE mesh generator, I wanted to go a little bit through this part of the FE mesh generator, because that was not really covered in the tutorial. And basically what we were using there was just this button for preview the mesh. And beside that, there is preview T3D geometry that is showing you which geometry can be meshed already, because it has assigned those building element types. So for example, if I go back to here, and we have here just the geometry, we didn't assign any materials, any building element types, anything, and I press this T3D geometry, there is basically nothing to create mesh on yet, because there is no T3D geometry for meshing. And here you can see that it's nicely, and when I go back and go to T3D geometry, you can see that this part can be meshed already. Yeah, beside the view, you can also see the IMP file here. There is either IMP file for T3D geometry or already for the FE mesh, and it's mostly the same. It's you have the standard information in IMP file that describes the task, and there is material definition. And what we are interested in is this T3D data block, which is describing the geometry.
Maybe I will just interrupt, Michala, if I can maybe describe it. Maybe not all of you know what is this input file. Yes. Basically, this is what is driving. This is the command file for the subsequent nonlinear analysis, as was shown in the introduction when you run ATENA. One interesting thing to note now in this new version of ATENA is that actually the nonlinear analysis is being driven not by the direct mesh definition, but this input file, this command file for nonlinear analysis, actually contains the geometry. That's what Michaela is showing now. So there is this section T3D generate, and if you, Michaela, go down, so there is a section defining the geometry and also the meshing parameters. So if you look at this input file, you will not find the mesh definition. There is actually the geometry. And so once you start ATENA, in this case, typically ATENA Studio, at the beginning, the program is using this geometry information to generate the finite element mesh, and then it starts the nonlinear analysis. This is maybe sometimes useful because, for instance, if you want to do some parametric studies, typically in previous ATENA versions, you could only parameterize or change the material parameters. Now you can also change the geometry. So this is a little bit new concept, and maybe it's good to mention it now. Yeah, so please, Michal, go on.
Yeah. Okay, so this is like the ISB file for the geometry. But when we click on show FE mesh, it's basically the same file, but it includes also this command for creating the mesh on the geometry that is below. And here in this command line, you can see some parameters, and actually those parameters you can read in this part, for example. And there are more parameters that can appear in that command line. For example, if I check two checkboxes in here and I redo that IMP file, you can see that there are more commands. And basically all the checkboxes here have their command. I don't really want to go through all of them, but one thing I wanted to point out where you can find the more information about these commands. It's like we are talking about T3D, our mesh generator that we are using in Preprocessor, and that is something that you can find when you go to our documentation. And there is this PDF file T3D that is like explaining how this machine is working. So you can find, for example, we were looking here, there's checkbox for silent mode, and that -Q is like the command. So we search in this PDF for silent mode. You can actually see that it's like these command line options. There is a silent mode, there are explanations about it, and there are more commands that are explained in here. And these are exactly the commands that you can find in this section. I wanted to go a little bit deeper in this part that is regarding like the size of the geometry, because at this point we actually have data for the geometry that were defined in here. And here, like, there are default size of the mesh and uniform size of the mesh. And that is something that you can also read in those like text boxes, some more explanation about it, that the default mesh is assigned to vertices or the points with zero mesh size specification. So it's in the case that you didn't specify anything in here for the points, or this uniform mesh size is propagated all over the model entities. One thing that I would like to maybe mention here is that when you are working with these two, it's basically selecting most of it's selecting the smaller size. And when we are talking about the model, you are maybe focused on all entities, not just the points that are in default mesh size. And another thing is that you have some sizes that are defined in here, like specifically for geometry parts, which is like 0.1 or 0.05. But in case of you define here something smaller than those sizes in here, it will actually select the smaller size. So if I put here like 0.05, which is like on that middle part, And here I have just 0.1. It should here change this mesh to 0.05 if I define here something smaller than in that specific part geometry. And yeah, it's visible that it happens. So the smaller sizes where they are defined, they're like the ones that are actually applied on the model. So maybe I mesh it back. Then there is this default curve density, which you can again read yourself, that it's like the ratio between length of the curve and the density that you are setting in here. So basically what it says, it's like if you set the density to 10, that in case of most of the curves, it will divide it into pieces. It's like just the upper bound for it, that it will divide it into pieces, but there are some parts that were already defined specifically in here, and they are even smaller. So it will, this part will just be applied again only on the pieces where it makes smaller mesh than defined specifically locally. So when I define it in here, it will change along the like smaller parts of the geometry. So when I go back to number 1, it's according to this local settings. Yeah. So when we continue in here, it's like another thing is user defined epsilon. It's for geometrical ambiguity. So it's basically the tolerance for the distances. Then there is mesh size multiplication factor, and it's factor that you can use without changing, like if you have more specified sizes of the mesh throughout your geometry, you can actually use this multiplication factor for all of them at once, that you don't have to manually to go through all of the settings and change them, but this is changing them at once. So for example, you can see what size of mesh I have in here, and if I, instead of 1, I will divide it or multiply it by 0.5, so it should make smaller mesh everywhere because it's multiplying it. So this is like the factor that you can use all over. And then we are getting to the default curvature rate. It is something.
Just by my small note, this mesh size factor, this may be useful if you want to make some mesh sensitivity studies. So with this factor, you can easily, for instance, make the mesh twice as fine as some original mesh. So this may be useful for such mesh sensitivity studies.
Yes, great, thank you. Yes, I was talking about the curvature rate. That is part where you are defining the mesh for the curved part of the geometry, which we have, for example, in here, in the edges of the opening that are rounded. And with this curvature rate factor, you can actually make that curvature that is finer than other mesh, for example. So if you go, it's like, as it is set again here, like controls the ratio between the mesh size and radius of the curvature. So if we make it smaller, it makes finer mesh just along the curves, which we have in this model only in here. And again, there is this multiplication factor that can multiply it and apply it on this default curvature rate. So if we double it in here. That means that it should make like half of the half of the number of the elements that are there now. Yes, so that is the curvature rate. And then we are getting to these final two parts. One is the geometry type, if we are using like the linear or quadratic. And I think what's worth mentioning it in here is in case of you want quadratic mesh, even if it is just on the part of the structure, this is like global settings, so it should be always quadratic if you want some parts quadratic, because other parts you can set locally as a linear mesh in here, and it's actually in building element types. And if you actually do that, you have the global linear one and you assign locally the quadratic one, it will be omitted. So it's always, if you assume that you are using even partially quadratic mesh, it should be globally quadratic, and the linear mesh should be assigned locally. And this final part, it's this mid-nodes conflict that is actually in case of you combine those two types of meshes, like linear and quadratic, because they don't, when you combine them and they are like on the edge where they are meeting, these two meshes, they don't have the same number of the points. And it's always good to check in your analysis if when the structure is deforming, whether it is connected in these regions properly or not. If the deformation is like as it should be, or if there is some extra opening because those points aren't properly connected or not. So that can be remedied in this section if there is some conflict with those nodes.
Yeah, I think, Michaela, we are slowly coming to the end of at least of the official time. So I think we covered not everything because there are a lot of features, a lot of possibilities. I think it is still a good idea to go through the tutorial. Now we will also provide this recording, so you can go through it also step by step. We'll probably we'll prepare some more tutorials in the future or more webinars, maybe focusing on some individual issues in the modeling. For that, it would be very nice to have your input also, maybe which topics you would like to cover. And so that we have still some time for some questions and discussion. Are there any questions? There were no questions during the talk, so I'm not sure if everything was so clear, or if you were lost. It would be interesting to have some feedback from you.
I have one question.
Yes.
Like you mentioned that we can collapse and separate of geometry. So can we use the same function for the surfaces? Like, can we collapse two surfaces?
Yes, you can.
Yes, it's actually, I'll show it on that other part. In here, when you are using either tools like separate or collapse, it gives you option here which type of geometry you want to choose, whether you are working like with surfaces, solids, curves, or points, or even the interfaces. So you can choose whichever geometry you want for collapsing or separating.
The answer is yes, it works also for the surfaces, and especially there it is useful for collapsing, yes. And
Okay, thank you so much.
this separation may be sometimes useful for interface elements. Yes, if you have what we sometimes like to do, if you are building a model which contains some internal interfaces. So sometimes it is useful to define the model without the duplicated surfaces, and later use this separation command to create a duplicated surface and then to place the interface element there. Actually, I prefer personally two approaches: either use this separation command or just take one part of the model and move it out and move it back. And as we move it out, then all the surfaces are duplicated. Then you have to move it back. When moving back, you have to be careful to deactivate the collapse option. And then the result is that you will have some duplicated entities, and then you can define interface elements between them.
Okay, we have some questions. Maybe I can reply to the first one. I would like to ask Jan maybe to read something about cyclic loading. There's another question if you can answer it on.
Okay, yes, there are some questions in the chat.
There is like a question what is not implemented in the preprocessor, and there are like problem types or bond parameters. Maybe I will just quickly show you that there are actually bond parameters. It's sorry, there has to be already the material. So if I go to the bar and reinforcing types, there is like possibility to choose different bond types. So you can define the bond, and there is there is basically it's very similar definition of bond if you use our previous preprocessor GID, that there is like a possibility to generate according to Big I law, and there are also some dependencies that you can use on that bond law. And in general, what is not in preprocessor, I think Jan can definitely say more about it, but I think that the crucial part here is that we are working now in static, like that we have only static analysis, and we are implementing now the transport that should be available as the next step, that there is like heat and moisture conduction for our analysis. And then there should be also available later on creep and dynamic, but those are the parts that are not implemented yet, like the crucial ones.
I may add to that, the temperature module and moisture module will be released before the end of this year. This will be the new version, which we will call 2025. So it should be, I think, beta version will be released this year, but full version will be at the end of the year or very early beginning next year. There was a question about cyclic. Well, the models for reinforcement and concrete, they currently support cyclic behavior. So strictly speaking, you don't need any user material, but user material in general, it is possible to write a user-defined material in ATENA. There is a special manual for that if you look at the ATENA manuals, at ATENA documentation. And the bond slip between concrete and reinforcement, I think that was already covered by a little bit by Michaela. Yeah, it is just a matter that you go to the properties of the reinforcement, and there you can activate the bond slip behavior. In ATENA, it works such, very briefly, that the reinforcement is always defined independently of the solid material. Then when the program starts, it decomposes the reinforcement bar into small truss elements. Each truss element is then connected to the solid mesh around it. And to activate the slip, we are just adding additional degrees of freedom to these reinforcement nodes. And these additional degrees of freedom, they represent slip. And then there is a special iterative process at each iteration, at each load step, to calculate these slips. And there is a special slip law which controls that. The slip law, Michael showed you, we have some predefined slip laws like the FIB model code or Big I model code, but the user can define his own slip law if he needs to. So with that, I think we are already 10 minutes late. So for the sake, so that everybody can keep to his schedule. So I thank you very much for your interest in ATENA and participating in this webinar. We'll be providing to the registered users also a link to the recording. So thank you again for your attention. Thank you, Michaela, for doing most of the presentation. And
Thank you very much again, and sorry about those complications at the beginning.
Yes, we had some technical issues at the beginning. I apologize for that also, yes. Okay, so thank you again, and with this I'm concluding and closing this webinar. Thank you and goodbye.
Bye-bye.
Thank you so much.
Goodbye.
ATENA program produced by Chervenka company. You can find us via the website and download the program from it, or on YouTube by name Chervenka Consulting, or in Facebook by name ATENA. Finally, we thank you for your attention, and for any inquiries, please don't hesitate to contact us. Have a nice day. Bye bye.